Hello, we are Matchas and we will be presenting on the topic Safety Device to Prevent Sudden Acceleration and Avoid Accidents in Electric Vehicles. The index for our presentation is as follows. Electric mobility devices generate power using electric motors or batteries and include electric carts such as golf carts and yogurt carts, as well as small mobility devices like electric scooters. With the increasing prevalence of these electric mobility devices, incidents involving personal injury are also on the rise. Although their speed is significantly lower compared to automobiles, they can still lead to severe accidents. Therefore, this study aims to develop a safety device to prevent dangerous situations where low speed can result in significant accidents. This safety device can be installed as needed and is primarily intended to prevent unexpected accidents in areas with high pedestrian traffic. The experiments for developing the safety device utilized cylinders, springs, fluids, and ultrasonic sensors. Cylinder refers to an enclosed space containing fluid. The boundaries of the cylinder apply pressure to the fluid, causing the piston to move. Piston, located within the cylinder, it compresses the fluid when external force is applied. The movement of the piston changes the pressure within the cylinder, and this pressure change generates braking force. Spring returns the piston to its original position. When the external force is removed, the spring pushes the piston back, relieving the fluid pressure. Fluid. Due to its incompressibility, the pressure within the cylinder increases when an external force, such as rapid acceleration or deceleration of a vehicle, is applied. This pressure is transmitted uniformly through the piston. As a result, the vehicle's acceleration or deceleration occurs smoothly, maintaining a safe speed. In other words, the fluid absorbed applied force, regulating the speed during the acceleration. Ultrasonic sensor, used in conjunction with a microcontroller to measure the brief contraction of the cylinder when a certain pressure is applied to the top of the cylinder. Since pressure and fluid play crucial roles in the experiment, concepts from fluid dynamics and kinetics were applied. The experiment has two main objectives. First, to analyze and measure its factor acting within the cylinder. Second, to indirectly verify the effectiveness of the safety device based on experimental results. The material required for the experiment are as follows. Experiments 01 and 02 are friction measurement experiments. The left side examines the friction between the cylinder and piston, while the right side examines the friction between the roller ring and piston rod. Experiment 1 investigates the behavior of air within an enclosed space. It examines how the expansion and compression of air within the cylinder bounded by the piston affect the piston's motion. Experiment 2 investigates the interaction between the moving parts and the fluid. It assesses how the fluid impacts the piston's movement based on the measured values. The next experiment evaluates the stability of air pressure, checking if the fluid cannot clearly resist the sudden expansion of air when the piston reciprocates. The final experiment evaluates the stability of the spring elasticity, determining if the spring is appropriate for the experiment's purpose. Next is the Arduino code for the ultrasonic sensor used in the experiment. The measurement frequency of the ultrasonic sensor is 2400 Hz with Arduino Uno, and the measurement values were organized using Excel. MATLAB was used to obtain graphs related to distance, speed, and acceleration from the organized Excel data. Additionally, curve fitting was applied to obtain linear graphs for easier control. Here are the graphs generated using MATLAB. The decrease in speed over time when a load is applied to the cylinder indicates that the safety device gradually absorbs kinetic energy, controlling the movement of the rod. The curve fitting results also show the linear decrease in speed, indicating that the piston's movement is predictable. This predictability simplifies the control and design of the safety device. This is the anticipated design of the safety device based on the experimental process and results. As shown on the right, as the piston moves, the fluid is compressed or the spring extends. This increases the fluid resistance and the springs restoring force, thereby reducing the piston speed. The safety device is expected to provide benefits such as shock absorption, enhanced stability, and ease of control. Additionally, it can assist electric vehicle drivers accustomed to internal combustion engines in achieving smooth pedal operation, preventing motion sickness caused by regenerative braking.